So yeah, welcome. This is the Stratum P2 PR Review Club, and we have a few contributors from the community here with me on the voice channel, and together we're gonna look into this pull request here that's living on Stratum, GitHub.com, Stratum Mining, Stratum pull request number 977. So I should give some context on this pull request, right? Here on SRI, we have the examples directory, and inside the examples directory, we have many examples, right? This is a common pattern in Rust projects. You have an examples directory, and then you have little crates that are sort of like teaching you how to use the APIs. And uh, recently, I've been exploring the framing SV2 crate as well as the codec and the binary SV2 crate. And I felt like I needed some exercise to really make sure that I understood how to use those crates correctly. I understand their relationship. And so first I started exploring the ping pong without noise example because it is a natural place to start if you want to learn about these crates, right? Uh, and we're choosing the without noise option because we're not doing encryption, right? These connections are happening in plain text. Uh, but we're doing the binary framing. And that is essentially how we're learning how to manage this binary framing so that we can declare uh, messages in Rust and make sure that the SRI is able to convert those messages into SV2 frames, the binary encoding under the spec. So I started reading this example, and it's very good. It teaches you the basics, but it has some complexity that is unnecessary in terms of logic that is done here on the main. And because basically we're establishing an imaginary ping pong protocol here, right? And this code is doing a lot of fancy things with the ping pong messages, and we don't need all that. We just need to send a message, receive a response, and that's it. So that was my mindset when I rewrote it, and I wanted to start from scratch. So first, I added a commit removing entirely this crate, and I started from scratch, right? And that is the Git history after this first commit. Uh, so, does anyone have any questions at this point? To all the SRI community contributors on the room.
I think I'm not. Like, I'm not sure what's the problem with the previous example. Like, what are you changing exactly from the previous one to
It's
this one?
been a while since I read this code, but it's taking arguments from the command line, and then it keeps sending ping pong back and forth like indefinitely. And then the way you handle some channels here, it gets more complicated than it needs to be, right? It's not a big deal. And also, for my own learning experience, I wanted to go through the task of writing essentially this function. Uh, so you can see here all these comments, I added them, right, as I was looking into each step in isolation. So okay, here we're creating the message, here we're creating the frame, here we're encoding the frame. Here there's this little gotcha on the API of framing SE2 crate, and I saw that you asked a question there. This solution seems to be in the right direction. And to answer uh, your question here, why are we taking this approach? This is just technical debt. The time when the previous developers were writing this, they had a lot on their plate, as is common in our day-to-day life in SRI development. We're a very small team. Sometimes we need to shuffle our attention between multiple things, and probably when they were writing this, they got it to work, they got it to compile, they got it to do what it needed to do. But when you're trying to read it and you're trying to make sense of it, it's not the best design. So there is room for improvement there, which I started. Uh, well, first I started writing the Rust docs for crates, right? We still have a long way to go, but uh, I did framing SD2. So that PR was just adding comments, right? It was just like, hey, these are comments so that when we do cargo doc, uh, it's gonna render nicely into something like this. And we can navigate it, we can read things here. This is actually the old version. Let me see if I can find the hosted. Yeah, so this is the updated version. And so after I wrote this, uh, I I wrote this issue with a bunch of things that I noticed that were essentially technical debt in that code, and I saw that as I sent a PR for this one. Actually, more than one, right? You're breaking it into smaller tasks. Is that correct?
Yeah, the first one is more about the header and
Mm-hmm.
removing the frame trait, and then the second one is more about the framing.rs file.
Mm-hmm.
But still, it's not doing much of code changes. It's mainly about renaming, reordering, and doing that stuff. I think there are a couple of functions that we would need to
Mm-hmm.
just change a bit. But
Awesome. Yeah, we
yeah,
can
do
we
you
can do it
know?
incrementally. There's no problem. Say that again.
Yeah, do you know maybe? Uh, like, do you have it written here? What's that bug that it's causing the requirement to read twice before it's successful, or is that was not debugged?
It's not a bug per se. It's related to the frame trait. If you look at the design of this framing 2.rs, you're gonna find it declares a frame trait, and then when they were designing this code, they thought, okay, I'm gonna have the same trait for SV2 frames as well as for noise frames. Uh, but it turns out that wasn't a very good decision, because then you need to have one common API that works for both uh, types, and it just gets a little bit awkward in some edge cases. So when I was writing this issue, made it, I removed that trait completely as just as an exercise. Like, can I get rid of this trait? And like I just, with very little tweaks to the code, the compiler worked. So we're never using this trait as a trait bound anywhere. We're not using it for generics. It's just they're creating technical debt. We don't need it. Uh, does that make sense? Does that answer your question? Is it clicking to you?
No, yeah, yeah. I was able also to just remove it, and
Uh
everything
huh.
looks fine. Yeah, yeah.
So
Let's see. Maybe that will solve also the problem with the reading.
yeah, because that is just you were asking about uh, right now. Yeah, it's the way, the sequence that you need to do with the decoder. It's very not, it's very counterintuitive, and it's a result of those APIs. And I think we can improve this. I don't have a concrete plan on how to proceed. I just pointed out the things that can be improved. And I must confess I haven't looked into your PRs very closely yet because I wanted to do this first, right? I wanted to make sure
Mm.
that we did this kind of thing together. Looking at the ping pong example, because the ping pong example is really good to give the foundation on how to use those traits. Uh, sorry, those crates. So yeah, let's keep going. Uh, so maybe let's start looking into the code. And the code changes. Close the stuff. Okay. So yeah, these were removed. Uh, Here we declare cargo tomo. Uh, we only declare binary SV2 and codec SV2, and still this is an example usage of framing SV2 because it is actually just re-exported by codec SV2. Uh, and I'm not sure what the reason for that is. It might be technical debt too. I'm not sure. Uh, but that's just to point out that hey, we're not explicitly declaring framing SV2 as a dependency here, but we are getting it as part of codec SV2. Maybe that means that both framing SV2 and codec SV2 could be the same crate, right? And that is sort of an idea to keep in mind for the longer future when we start doing deeper refactorings to the code base. We have some ideas drafted for that, but it's probably gonna take a while before we start doing those deeper changes to the code that would, for example, unify different crates into uh, a single crate. That is probably on the timeline for 2025. I'm just saying this now so you guys are aware of it. So yeah, this is the README file. It is listing framing SV2 here because it is relevant, even though it is not explicitly declared here. So we establish a simple ping pong protocol with the server and a client communicating over a TCP socket. The server expects to receive a ping message encoded as a Stratum v2 binary frame. The ping message contains a nonce, which is a U8 generated randomly by the client. So the client expects to get a bong message in response, also encoded as a Stratum v2 binary frame, and he expects to have the same nonce that he sent on his ping, right? If he gets a bong with a different nonce, there's something wrong there. So this values for binary framing, maybe I should look into the specs to give more context into this here. On the specs, we have message types, and we are essentially assigning 8 bits for each protocol message, right? And well, ping pong are not official Stratum messages, right? I just created this new protocol and I'm using arbitrary message types. So I just went to the other end and I just picked FF and FE because, well, there's no messages using them and it felt safe. Also, this is just a dummy example. This is never going to be used in production, so it feels safe to pick these numbers. And coming back to the files. So let me collapse this. So then we have, this is sort of the architecture of the ping pong example. We have a main file. which is very simple. It just declares some socket uh, that will be opened as a TCP socket. Uh, and so we spawn a thread which calls this server module there. We wait for that server thread to sort of bootstrap and do its work, and then we start a client thread, and we block on it because there's nothing to be done afterwards. So maybe let's look into the the messages. Let's look into messages. So this is like in the README explains, we're defining the binary values for the messages. Here we declare a struct for each message. We gotta make sure it follows these derives, so that then the binary SV2 create can do the serializing and deserializing correctly. We give them two little methods just for convenience. This one, the ping. The ping is a random number, right? We just, or pseudo random, right? Depending on how strict you are about your definitions. But so the client generates a nonce, right? And the pong, we have a constructor there, new, that takes the nonce into the constructor. So it's not randomly generated. The pong is deterministically generated by the ping. So these are our messages. So maybe let's look into, should we start client or server? Which one do you guys want to look into? Maybe let's start on client, because there's some questions asked here. So basically, we just have one function there, and this function is meant to be called here, right? On the main. And that is start client. It takes the address for the TCP socket. It creates a TCP stream, create the message, create the frame. So that is the first step. With the message that we declared on messages.rs, we use this generic here on the standard SV2 frame, and we say, hey, this is what my frame is encoding. Please take this struct, look into how you're gonna serialize and deserialize it from the binary SV2 crate, and yeah, just make sure that these frames are correctly created, right? And so when we create a frame object, we just sort of declared it to memory. It's not properly encoded yet, right? It has the sort of unencoded version in memory, which is the ping object, but it hasn't serialized it into binary format yet. So for that, we create an encoder object, and then we use this encoder to write the binary encoding into the ping frame object. And now it is ready to be sent over the wire. So we take our TCP stream and we write the bytes, the raw bytes. And from that point on, we have successfully sent a ping message to the server. Now it's time to listen and receive and verify the pong response. So Ezra asked here, why does the first read fail And that is a very good question that I also asked myself, and it took a long time to realize. The answer is gonna lie here. If you come here, you're gonna realize that, hey, you come here onto the framing to create. We have the frame trait here, and it establishes this common API that is used for both SV2 frame as well as handshake frame. And the important thing to realize here is the fact that handshake frame is only used on the context of encrypted connections. So it brings in new abstractions. And by the way, there's no encryption here on this ping pong example. Remember, this is coming from the without noise example. So we only need to use the SV2 frame struct here, but both these structs are implementing the frame trait. And as a result, when you are reading a frame, the first thing you do, you initialize a decoder, right? You tell it, hey, what kind of message are you gonna be decoding? And then you get a buffer from it, right? From this writable object. Sorry, this writable method. Then you read into this buffer from the TCP stream, but you're only gonna read the header. And that is because that's how the decoder is initialized. So you get the header, now you know how big the frame is, and you can do a checksum on the when you read the second time, and you can make sure that it's gonna provide you with the correct number of bytes in memory, and you know that that is correct number of bytes because you read them from the header. So that is essentially why we have a two-step reading process here. First we read the header, then we read the entire frame. And maybe there's a better way to achieve this if we did not have the frame trait. I have not tested this alternative implementation, so I don't know if the APIs will really be better, but I think they will. Because basically, when you're calling SV2 frame, the way you're dealing with the payload here, there is some redundancy here on SV2 frame because we have the header, we have an object for a payload, and we have an object, a struct, a member in the struct that is representing the serialized header plus payload. So when we initialize the SV2 frame struct, this is a none, right? So here's the default. So both payload and serialized are none. So the first read takes a header and puts a header here. The second read takes the payload and puts the payload here. And then when you do next frame, if you look at the next frame API, Oh, next frame API is on codec SV2. Yeah, that's right. Uh, so these are just the re-exports that it is doing, then standard decoder. And well, the script is not very well documented yet, but the main point here is that we have the noise without noise struct, which I'm also suggesting that we rename it somewhere here, or no, maybe I have it in some other notes. Uh, but the point is, next frame, right? Next frame is gonna take and populate the serialized. So after we do next frame, this is gonna be populated, and finally the SV2 frame has the binary encoding. Uh, sorry, this is the other way around, right? We are decoding it. So we first we took this serialized, and then on the second step we populated this one, these two, right? Header and payload. Is it clear? Is it?
Yeah, why is the payload an option P and not just like an U8 or some other? Why it's a generic?
I remember asking myself the same question, and that is related to uh, the binary, the way the binary uh, SV2 create is structured. I still need to go over it in more detail, but I know that the way it is created has some implications. And we're also using, I think it's because of this buffer SV2. We're using the buffer SV2. Forget where. V2 RG buffer SV2 binary, yeah. So that generic has to do with this crate. I wish my knowledge was more extensive for me to give you a better answer. Uh, maybe we
Yeah,
can.
we can look into it later. I was just wondering.
Uh huh. So I think it's because of this. Those generics are bound to these traits, and then we use this for a more efficient binary serialization when compared to whatever was the other option for doing this. Uh, Let me come back to where I stopped. So, well, it's pretty much it, right? It's these steps are repeated with the correct logic on the. So here on the server side, uh, we have this start server. Uh, function, which is basically the thread that we spawn from main, and we're also uh, spawning a new thread here on handle client, which is taking care of the stream that's coming in. And this is probably unnecessary. Maybe I could just block here. Yeah, I'm not sure about this. But then, yeah, we do the same thing. Same steps here. And we decode it. We read the ping nonce, which is kind of an important step, right? We're making sure that, hey, we had a binary packet, and now we are deciphering it. We are making sense from what it was meant to carry the meaning. And in this case, is what is the nonce? Which number is it? So we assign it to this variable here when we're doing this pattern. So here we're using the binary SV2 create from bytes, and we give it the frame payload. And maybe we should look into that option from bytes. Here it is. Well, it's still not documented, so but still, I think this connects a little bit to your question, Ezra, because here we have a generic here, and this is binding to the decodable trait that I just pointed out, right? So I hope this is helping click some things for you. And so yeah, it takes frame.payload as input. So here it is taking just raw bytes, just a slice of U8, right? And this is the payload that lives in the SV2 frame object. So it's this one. So yeah, I think we finally have at least a partial answer to your question. Here we declared the SV2 frame trait with this generic that defines the serialization method for this, and then here we make sure T is decodable, and then we take in some slice of U8, right? Another method that is relevant for this, if I recall correctly, is this one, serialize, because it chooses which method it's gonna be using. We have some feature flags here with SERDI and without SERDI. From what Filippo told me, it seems that the goal is to eventually get rid of SERDI. So we would eventually just end up with these parts of the implementation. And when we call this, we call to writer, which is coming from binary SV2. And yeah, that is putting it's basically filling this buffer, right? DSD, Destiny buffer. So the yeah, I mean, these crates are kind of convoluted. The way they are codependent, in my opinion, is not ideal. Uh, it is awesome because they work, and that allows the Bitcoin community to start prototyping on Stratum V2. But it doesn't scale well in the long term. We need to do something about it. That comes back to this. If you guys think that there's potential improvements that you saw that I didn't see, right? Because I'm sure I'm having a lot of blind spots here. This is my own learning experience too. So if you have ideas that maybe you're trying to clarify in your own mind, uh, please feel free to dive into this issue, write comments here, tag me, and also FI3 because he wrote these libraries originally, so he knows them very closely, and he'll have the best advice for us on how to take these APIs and make them really good for the community to use. So, do you guys want to ask any other question about the code, or should I do a demo of this example? Should I run it and sort of go through it, the terminal? Are you guys still there? Can you hear me?
Yep. So if you can execute it, that would be great.
Say that again. Can you repeat?
Yep. So if you can execute it, that would be great.
If I could, sorry, I did not understand what you said.
Yeah, if you can
Oh,
run
my
it,
bad. Uh,
if you can
I'll run it.
execute
Yeah.
the code.
Ah, okay, sorry. So let's open a new terminal. Stratum samples ping pong cargo run. Whoops. Oh, I wasn't. Sorry, I was developing, and I don't have this branch checked out locally yet. Okay, git checkout hash git fetch web hash. Git checkout refactor ping pong. Just clean up this stuff here. Nope. Okay, that doesn't matter. Cargo run. Alright, so it's a very simple execution flow. If we look at the main again, we'll see that there's not too much going on if you sort of understand the logic and how it is encapsulated. So spawn a thread, we start server, we sleep, start a client. Server starts listening, client connects, it's all the same socket inside the same machine. Client sends ping to server with this nonce. If I execute it again, it's going to be a different nonce because I use the random number generation of Rust. So yeah, ping pong, right? Finally, the client prints out, hey, I got a pong with the identical nonce. So this protocol works, right? The APIs have some improvement to be done, but this should be a go-to example right now that sort of accompanies uh, things like the Rust docs, right? So perhaps even as we refactor uh, as Ezra works on these PRs that are being attached to issue 903, one good thing that we could do is to add a paragraph here on the crate description saying, hey, I mean, of course, this would be after we merge this, right? But it would be good to redirect people whenever they arrive here on this Rust docs for framing SV2. They have something that points them to coming to SRI and finding the ping pong example, and they'll be able to use this also to learn how to use those APIs. Does that make sense to you guys?
Yeah.
Awesome. So, uh, if you guys are happy with it, maybe give me an approval here on GitHub. Give me a thumbs up so we can hopefully merge this with consensus of the rest of the community soon. But also, this recording will be uploaded to YouTube, and hopefully it'll help the community learn about what we're doing and get involved with SRI development. So, if I remember correctly, it was BitAlu that was interested in doing some unit tests, and then I suggested to reach out to Ezra so you guys could discuss potentially doing that, merging your efforts. Which PR was that? I'm kind of lost. I cannot find it. Can you guys maybe share the link over Discord?
Yeah, it's this. It's the first PR that you see in the
It's the
list.
draft PR.
This one?
Top
No,
one.
no.
Oh, it's the draft one.
Yep.
Yes. Yeah. Okay, so. Okay. Yeah. Oh, you guys have been saying a lot of stuff here. I didn't catch up to this yet. I need to read this carefully at some other time. But the idea, I mean, while we are refactoring this crate, it is a very good idea to add unit tests, right? So that all this behavior that we're mapping here on the ping pong example, this is the expected use of these crates, right? This is sort of how the manual guide for them. And we gotta make sure that they work as we're telling people how to work, how they work. So unit tests are very welcome here, and I think it's just you guys. From what I've seen, you know a lot of Rust skills, so it shouldn't be a challenge for you guys if you want to contribute on this. So yeah, awesome. Thanks a lot, guys, for taking the time and doing this collaborative effort for the Stratum V2 community. And I hope we can continue working on these and being more productive to move SRI forward.
Good. Thank you very much.
All right. See you guys
Thank
later.
you.